as I mentioned before, all ionic compounds, just because water is very polar and ions have the ion-ion attraction, all salts are not soluble. It depends on, this give and take of can the water overcome the ion-ion force. And there's a classification kind of scheme where you can, uh, evidence shows that all salts that have sodium, potassium, or ammonium ion are soluble in water. All salts of nitrates are soluble in water. Most chlorides are soluble in water, but silver chloride is not. Um, most sulfates are also soluble, but there's some exceptions. And then most carbonates, carbonate is CO3 minus 2, those are mostly insoluble. And most salts that have hydroxides and sulfides are also insoluble, except for those that are made with the group 1, and these are group 1, sodium and potassium and ammonium. Those will be soluble. So for example, potassium hydroxide is soluble, aluminum hydroxide is not. So there's these solubility tables, this is an example of one, where you can kind of get a feel for which salts are going to be soluble and which are not. You don't need to memorize this, you just need to be aware that there are tables available for people to predict whether or not a particular salt is going to be soluble or not. And there's environmental consequences of this, as you can imagine. If water gets near a soluble salt that happens to be deposited in the earth, then it's going to dissolve it. For example, there are regions where there are salt deposits like sodium and potassium halides, sodium and fluoride, sodium chloride, that's what that means, sodium iodide, potassium iodide. These deposits are scattered throughout the earth. They're soluble, and over time they dissolve from the land and wash into the sea. That's why the oceans are salty, and seawater can't be used for drinking without expensive purification. Okay, this is real important because these salts are so soluble over time. These ions have made their way into the oceans. And then other sources for other salts, nitrates, they're soluble, and so that can be dangerous if there's too much fertilizer draining just into the waterways. Metal ores are typically insoluble, which is why we still have a lot of metal ores in the Earth's crust, because over time they have not dissolved quite so easily in the water. And then mining waste, after certain elements have been mined, there's waste, especially just even from the coal industry and whatnot, and that would be lead and mercury. And they're mostly insoluble, but over time they will leach slowly because the solubility is low. So it's not like it's going to dissolve 100% right away, but over time they will leach into the rivers and lakes and be able to contaminate the water supplies. So you can see here there are environmental consequences of the fact that salts are soluble in water.